Hello, this is Professor Keen, and this is Introduction to Astronomy. Let's jump into Chapter 4 of Book 2 of Aristotle's On the Heavens. Now, the question, as I mentioned at the end of last lecture, that he's going to be asking here, and I'll write it out, the main question that he starts out with is, what is the shape of the heavens? What is the shape of, I think he even says the body of the heavens. So you've got this, these stars, the moon, the planets up in the sky, and he's not asking about the shape of those individual bodies like the stars, the moon, the planets. He's talking about the whole thing. So what is the shape of this large body that appears to be revolving around us? And let's just jump right to his answer, and then we'll talk about some of the rationale, some of the reasons he gives for his answer. And he says it is spherical in shape. In fact, it's a perfect sphere. That's his answer. Now the question is why? Why does he think that it is spherical in shape? And he gives a number of reasons. And I'm not going to go through all these in the exact order that he gives them in. If you want to look at the order, you can look over here at Chapter 2. And if we jump ahead right here, we're in Book 4, which is at the bottom of the page here. And he says, you can see right away, he says, the shape of the heaven is of necessity spherical, for that is a shape most appropriate to its substance and also by nature primary. So there's going to be a number of reasons that he gives over the next couple pages. Let's jump ahead to, I think, his second reason or so. I don't know how we want to order these, but one of the reasons, so what are the reasons for this? I'm just going to kind of number them, although, again, they're not the same order that he gives. And the first reason that I'm going to talk about is he says, well, the whole world, that is the heavens above us, revolves around us apparently in a circle. Heavens revolve around the earth. Heavens revolve around the earth in a circular motion. Okay, and this implies that it must be circular in shape. That seems like it would be the most natural shape for something that moves in a circle, that is moving around us, right? And again, here we have just some common sense. When you look up at the sky from night to night, you see things rise in the east, travel roughly overhead, and set in the west. This is happening repeatedly night after night after night. It appears to us that the stars are moving in a circular motion, and so it seems like it would be most natural for it to be circular. And moreover, what if it were not exactly circular? So what if it was, instead of circular, it was egg-shaped? He calls it oviform, or even bean-shaped, lentiform. So what if it was kind of, if this is the Earth here at the center, and what if this huge body on which the stars are located was not circular in shape, but kind of like an oval shaped? What would happen then? Well, notice that as this rotates around, this is the argument that he uses, as it rotates around us like this, let's say it's kind of swinging around like this, notice that there are going to be some parts of it that are inside of it at one point and outside of it at another point. So right here, if we pick out this point right here, at this moment where there's a dark line, it is inside of the world or the universe. But as the universe rotates like this, now that point is outside of the universe. And he says that doesn't really make any sense, to have certain places inside at certain times and other places outside at other times. The only shape that one could have that maintains whatever's inside of it at all times would be a circular shape, because as this rotates around, the points that are inside of it stay inside of it. Okay? So that's one of the arguments that he gives. Another argument that he gives is that the heavens move swiftly. or very quickly around us. They move swiftly around us. And he says the most natural thing to move most swiftly around us would be a circular object. So the most swift mover, or the most swift body, would naturally be a circle or a sphere, right? So if you think about if you wanted to have an object spinning around or rolling, you might think, it would make sense if it was a circle. It's not going to be as swift of a roller if it was a square. We don't make tires out of squares, right? We make them out of circles. So it's a natural shape. It would be a fast-moving shape, and that's the kind of thing that seems natural for the heavens, okay? Another argument that he gives, and again, if you're not happy with these arguments, that's okay, but he's seeing them as providing evidence or rationales for why it would make sense for the heavens themselves to be spherical in shape. Another one, and actually this is the first argument he gives, so I'm going to kind of come back to this now. He says that different shapes can be ranked differently. So shapes can be ranked or arranged by the number of sides they have. Okay, so the primary shape, or the first shape, I'll do this. The primary or first shape is a circle. Why? Because it has just one side, right? There's only one side to this circle. And then as you add sides to it, it becomes a secondary or tertiary or a fourth ranked shape and so on. So the third shape is a triangle. Why? Because it has three sides. So a triangle is the third ranked shape. The fourth ranked shape is a square. Okay? And so you can kind of rank these shapes according to the number of sides. And then what he does is he says, well, it would make sense for the primary body, that is the body that consists the heavens, the kind of the biggest thing in the universe, if that's the primary body, and the primary shape, the one that has the smallest number of sides, is a circle, then it would make sense for the primary or most important body to itself be a circle. So it would be natural, or it would be fitting for the heavens, which he calls the primary or first rank body, to have the form of the primary shape, or the first ranked shape. And again, you're likely not going to find this kind of argument convincing. I don't know, maybe you do, but he's trying to explain the rationale or the reason why the heavens might be circular in shape. It appears that they're moving around us in a circle, and it would be natural for them to move quickly around us, and here he's arguing for another reason. Okay, another reason, let me just mention this one also. He says this is corroborative evidence. So this would be on, I think, down here, I guess. I don't remember where it is. The corroborative evidence. He says, well, if the Earth itself is a sphere in shape, we know that. Notice he didn't think the Earth was flat, as some people might accuse the ancients of believing. He says, we know the Earth is circular in shape. We also know that the waters that are on the Earth, I know water doesn't cover the whole Earth, but imagine the waters on the Earth, those form a sphere in shape. And then presumably the air around us, the atmosphere, the air surrounding the Earth, is also spherical in shape. So this sphere is kind of a theme. And if you want to think about the things that are above the Earth that make up the heavens, since they're continuous with the sphere of the elements on the Earth, it would only make sense if those two are spheres kind of built up like onion skins on top. It seems like that's a weaker argument, but he's arguing that because of the shape of the Earth and the shape of the water, it would make sense if the things that surround the Earth are also spheres. So those are the arguments he provides us for the shape of the Earth in chapter 4. Let's pause there.